Okay, starting a little bit late, that's okay. Let's get this done while the old lady makes turkey burgers. Yum, turkey burgers. Okay, she said we were going to help with the algebra work, so let's do this. So first part, tell whether the function is quadratic. Remember, for it to be quadratic, the highest degree has to be 2, which means somewhere you have to have an x squared, and it has to be the highest degree in the equation, our function. So if we look at number 6, we have x squared, we have 9x, and we have a constant of 5. The highest degree is 2, so this is quadratic. Yes. Number 8, 1/2 x squared. X squared is the highest degree. That is quadratic. How about this one here? Negative 4x, no x squared. This is not. This is linear. Linear. And number 9, 5x cubed. That's not quadratic because it's x to the third. This is cubic. Alright, use table of values to graph each quadratic function. So table of values is just something that looks like x and y. Pick a couple values for x, -2, -1, 0, 1, 2. Perfectly straight lines. And then we just substitute our x values into our function and we work it out. So -2 squared is 4 times 6 is 24. Let's see, -1 squared is 1 times 6 is 6. 0, there's no c, so that's just 0. And then 1, again, since there's no c and our vertex is going to be at 0, 0, that means that since our axis of symmetry is also at 0, then our positive 1 and 2 is just going to mirror our y values for -1 and -2. So it's going to be 6 and 24. We could graph that, look something like this. It'll open upwards because a is positive, and since it's 6, that's going to be pretty well steep here. So you can imagine -224 is up there. Alright, same thing we could do with number 12. It's the same idea. The only thing we're going to notice is different this time is that we have a fraction, which means it's still going to open upwards. It's still positive, but it's going to be much wider. So we make our table of values here with our nice teal kind of color. Instead of using -2 and -1, those are going to give us fractional answers. Since my denominator is 4, I'm going to use multiples of 4. So -8, -4, 0, 4, and 8. So, wait, is that going to work? Yeah, that'll work. That'll be a little big, but that's okay. So -8 squared is 64. Divided by 4 is 16. -4 squared is 16. Divided by 4 is 4. 0 is just going to be 0. Again, that's the vertex, so this other side is just going to be split. I guess we could have done smaller numbers. We could have done like -4, -2, and 0. Right? That would have been a little bit smaller. Whatever. You get the idea. Here's our graph. Opens upwards, but it's kind of wide. Okay? It's like a kitten. And some whiskers. Okay. Tell whether the graph opens up or down. Explain. We went over this. If A is positive, it opens up. If A is negative, it opens down. Identify the vertex. Remember, the vertex is either the peak or the valley. In this case, is this point right here. Is that a minimum or the maximum? Since it's at the bottom, that is the lowest it can go, so it is the minimum. Okay, one part done. Next part. Pair widths of the graphs. Order them from narrowest to widest. So remember what we said. It gets narrower as it gets closer to 0. So 0 is most narrow. And if we had, like, I don't know, infinity, that would be the most steep. Wait, what does it say? From narrowest, or no, wait, why did I say narrow? I don't know my words. This is most wide. Sorry. Sorry, English escapes me. So something like 100 would be very narrow. Narrow. Okay. Remember we just said distance from 0, so negatives don't really matter. We just look at like the absolute value of a. So in this one here, 2x and 4x, which of these would be wider? This one would be wider, and this one would be narrower. Okay? 6x and negative 6x, well, those are exactly the same. So these would have the same width. Okay? X squared, if you don't see a number in front of that, remember that's just 1. So which of these would be the widest? Would it be the fraction, 1, or a 3? Well, the fraction will always be wider than a whole number. So this would be most, so we'll call this number 1. 1 or 3, which would be wider? 1 would be, and then 3 would be, third. Okay, so the greater the absolute value of a, the narrower it gets, or the steeper it gets. I like steeper is a better word than narrow, but you know, whatever. Compare the graphs. So this time we're looking, we don't really care about, well, I guess we can care a little bit about a. So how does x squared compare to x squared plus 5? Remember, if x squared, that's what we call our parent function, because that's what function, I don't know how to spell. Function. Everything else, every other quadratic formula is based on that. Remember, our x squared is our most basic looking little u. If we have x squared plus 5, it's going to be that exact same thing, only it would be further up. And our vertex, instead of being at 0, 0, would be at 0, 5. Okay? So that's that. If we had 3x squared, that would be more narrow or more steep than negative 1, which means our vertex would be down here on the negative side, and it would be more steeper. Okay? And then 2x plus 3. So our vertex would be, oops, I guess I should underline this for the sake of consistency. So plus 3 would be in between 0 and 5. 2x squared will be a little bit steep, but not quite as steep as our 3x. So this is getting kind of messy, but you can kind of get the idea. Maybe not. Maybe my drawing's not that great. Hold on. Still not that great. Whatever. You get the idea. It's in between x squared and 3x squared as far as steeptitude. Okie dokie. Next part. Solve these by graphing the related functions. So I found this neat thing. It'll graph it for me. So we can save ourselves some time. So x squared plus 4x plus 3. So we say x squared. Okay, we got that. Plus 4x. So plus 3. So plus. And we get a graph that kind of looks like that. Okay. Not so bad. Just right here. Okay. If we have something like this, 4x squared equals 3, we don't really want to graph that just like that. We want to make sure y is all by itself, or everything else on one side, and we just have 0 on the other side, because that's when things are happy. So 4x squared equals 3. We can say this can be negative 4x squared. If we move the 3 to the other side, instead of being positive, it would be negative. So what would that graph look like? Well, let me show you. So minus 4x. This would be nothing. Minus 3. And that's it. Okay. So we could have told you what this looked like without even graphing it. Negative 4x means it's going to open down. The 4 would mean it's going to be pretty narrow. And minus 3 means our vertex is going to be at this point 0, 3, since we have no b term here in the middle. Okay. Okay. And one more, let's just to show that we can do this without, we don't have a calculator or something to graph it for us. How can we do this? Let's take an easier one. I don't want to graph any of these. Oh, it says solve the equation, so really we're looking for the zeros there, so I should go rewind that and see where the zeros were if you want those answers. So negative 4x squared equals 64, blah, 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 blah. So we can write this out in a way that looks a little bit better. 4x squared equals, nope, oh, not equals. What am I doing? 4x squared. We move everything else over, so negative 32x will become positive 32x. Positive 64 will become minus 64. This graph's terrible. Okay, so what we can do, instead of making a table and trying to figure out which of these points would be the vertex, because that might take a while, is we can use our little formula to find the axis of symmetry, which remember is negative b divided by 2a. And so our b is 32. We want the negative of that, so we have negative 32 divided by 2 times a. Well, a is negative 4 here, so 2 times that will be negative 8. If we simplify that out, we get x equals positive 4, which means this line right here of x equals 4, perfectly straight lines. Here's our axis of symmetry. We can then find the vertex from there by simply substituting a 4 in place of x. So we would have negative 4 times 4 squared plus 32 times 4 minus 64. So 4 squared is 16. Yeah, 4 squared is 16. I'm forgetting what I'm doing. Times negative 4, negative 64. Plus 32 times 4 is 128. This is going to work out super nice here. Minus 64. Negative 64 minus 64 is negative 128. Plus 128 is, guess what? 0. Yay, you can hear it in the background. Which means our vertex is at this point 0, 4. Not 0, 4. 4, 0. 4, 0. My bad. My bad. Which means we're only going to have 1 0, because that's our 0 right there. It is going to open downwards, so it's going to go this way. So we just need to sort of pick some arbitrary other points here. Arbitrary meaning it doesn't really matter which ones we pick. Just something fun. So let's pick something a little bit smaller than 4. Let's pick, I don't know, 0. No, 0 is not going to work because that's too big. Oh, this graph still is bad. I don't like it. You know what? Forget it. Let's do 0. Kind of feel bad for making you do these. If you started doing these, stop doing this part. You don't have to graph these. Use a calculator. Okay, that's why we have technology. So 4 times 0 squared. I use 0 because this is gonna make everything cancel out. 32 times 0 minus 64. So we have 0 plus 0 minus 64. So we're gonna have this point at 0, negative 64. And my graph doesn't go that far. It'd be down here. No, wait. 0, 64 would be on the axis. So you can draw on this perfectly good not perfectly good curve. I might not be able to do this. Perfect. Alright, since the axis of symmetry acts as a mirror, that means if 0, negative 64 works, that means on the exact opposite side. So at 8, 64, we would also have a functional point. And you get a graph that looks kind of like that. And we probably want to erase our axis symmetry because that might be a little bit confusing to anyone who just started watching. So there's our graph. It's terrible and not that useful, but there it is. Okay, if anyone asks you how to graph stuff, now you know. Okay, that's that. Alright, last one. Solve equations by factoring. This is the preferred way to do it if you don't have a calculator because it doesn't require drawing pictures, and I don't like drawing pictures unless it's of stick people. Like that. Okay, solve by factoring. This first one's pretty easy. What adds to 9 and multiplies to 14? Well, that's x plus 2, x plus 7. 7 plus 2 is 9. 7 times 2 is 14. So what we want to do is we want to make either part of those, either of these terms, either left or the right, equal to 0. So how can we make x plus 2 equal 0? Well, that would be the case if x equaled negative 2. How can we make x plus 7 equal 0? That would be the case if x was negative 7. So solve our solve the equation by factoring. The solutions are the zeros. If I never told you that explicitly, I'm sorry, but that's the case. If it says solve it, it means find the zeros. Okay? Okay. Okay. That's that. Alright, next one. This one is the extra step here. 2x squared minus 2x minus 4. Well, we don't really like having this a term. We'd like to get rid of that at all possible before we have to do like tic-tac-toe and funky stuff. So fortunately, it's just a 2, and all these other ones are even, which means we have a greatest common factor of, you guessed it, 2. So we can factor out the 2. We're left with x squared minus 1x, or just minus x, minus 2, still equals 0. Then we just need to factor this whole mess here. So what adds to negative 1 and multiplies to negative 2? Well, that's not so bad. That's just x minus 2x plus 1. Only so many things that multiply to 2. It's pretty much just 2 and 1. We know that the 2's got to be negative because b is negative, which means the negative has to be greater than the positive value. So that's why this works. If you don't believe me, you can FOIL it. I'm not going to because we got stuff to do. And turkey burgers. How much time till turkey burgers? She's working on the potatoes, so turkey burgers incoming. Okay, so we want this to equal 0. This 2 doesn't really matter because if one of these equals 0, then 2 times 0 isn't going to do anything. It's still just going to be 0. Okay? So how can we make x minus 2 equal 0? Well, if x was positive 2. How can we make x plus 1 equal 0? If x was negative 1. That's right. It's easier than you think. If you can get past the factoring part, then finding the solutions, very simple. That's why we spent so much time on factoring and so little time on this, because this is easy. Easy-ish, I guess. If you're having trouble, I'm sorry for saying it's easy. Really, it's difficult. Really. 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 Alright, last one. I looked at this for a while and I was like, oh, this is a terrible equation. But then you think, well, I could tic-tac-toe this, but the numbers are really big, and 4 times 81 is like 320 something. I don't want to mess with that. But if we think 4 is perfect square, 81 is perfect square, so maybe we have the difference of squares here, or perfect square trinomials, and all that noise. So we rewrite this to get the right side to just be 0. So we can say 4x squared minus 36x. If we move negative 81 to the other side, it'll become positive 81. And then we'll just have 0 over here. And then if we think about it, 81 squared is 9. Or square root of 81 is 9. Square root of 4x squared is just 2x. So let's try that. If we say 2x, right? 2x, that gives us our 4x squared. Cool. We have 9 and 9. That gives us our c. 9 times 9 is 81. Now all we need is this negative 36 in the middle. So 2 times 9 is 18. 2 times 9 is also 18. That's a total of 36. That works, except this whole thing's negative, which means this has to be negative, and this has to be negative, and this is factored correctly. Say hooray. Somebody say hooray. Whatever. You get the idea. This whole thing equals 0. So now we just need to know, how do we make 2x minus 9 equal 0? We get x by itself. This is a two-step problem. It's still not that bad. We add 9 to either side. So 2x equals 9. Divide both sides by 2. And we get x. That's not an x, that's a 4. X equals 9/2. Alright? We could do that on the other side here. If we did this one, we could also do this side. But hey, guess what? Look, it's the same thing, which means the answer is still 9/2. So what does this mean? If there's only one answer, that means our vertex here is going to be at this point here. So it'd be 9/2, 0. Which means if we really wanted to, we could plug in 9/2, square it, times it by 4, minus 36 times 9/2 plus 81, and get a total of 0. Don't believe me? Alright, so 4.5 times 4.5, 20.25 times 4, 81. Uh-oh, here we go. Minus, parentheses, 36 times 4.5, in parentheses. Wait a minute. What happened here? Hold on. Ha ha ha, I'm not smart. I didn't hit enter, and that's why it's giving me the wrong number. So that equals negative 81. If we add 81 to that answer, guess what? We get 0, which is what we wanted. So our vertex is at the point negative, no, not negative, 4.5, 0. There's only one answer. If you work this out and both of your factors are the same, it means you're only going to have exactly one answer. Okay? So that's your homework. Benchmark tomorrow. Get excited, get some sleep, eat some breakfast, bring me some breakfast. A number 1 from Whataburger. I'll eat a couple of those. Okay? Like, comment, subscribe. Hit me up on Twitter. # do your homework. Bring me Whataburger.